Sharing a neutral wire on a 3-wire home run protected by 2 separate arc fault circuit breakers for 2-bedroom circuits is not permitted. Having 2 arc fault circuit breakers protecting the same neutral wire can cause nuisance tripping. If one circuit experiences an arc fault, both arc fault circuit breakers may trip, unnecessarily interrupting power to both bedroom circuits. According to the National Electrical Code, each branch circuit must have its own dedicated neutral conductor. Sharing a neutral conductor between 2 arc fault circuit breakers violates this requirement. To comply with the National Electrical Code and prevent nuisance tripping, you should run separate neutral conductors for each bedroom circuit. Each arc fault circuit breaker should protect its own neutral wire. An arc fault circuit interrupter, or arc fault circuit breaker, is a circuit breaker that breaks the circuit when it detects the electric arcs that are characteristic of some types of electrical faults. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults in electrical wiring. An arc fault is an unintentional electrical discharge between 2 or more conductors. Arcing faults can occur in a variety of locations, such as in damaged or deteriorated wiring, loose connections, and faulty appliances. When an arcing fault occurs, the electrical current can create a high-temperature arc that can ignite nearby combustible materials. Arc fault circuit interrupters are designed to detect these arcing faults and quickly shut off the power to the circuit, preventing a fire. Arc fault circuit interrupters work by monitoring the electrical current in the circuit and detecting the telltale signs of an arcing fault. These signs include rapid fluctuations in current, high-frequency noise, and the presence of non-sinusoidal waveforms. When an arc fault circuit interrupter detects an arcing fault, it trips the circuit breaker, cutting off the power to the circuit. Arc fault circuit interrupters are required by the National Electrical Code in many areas of the home, including bedrooms, living rooms, and dining rooms. They are typically installed in the electrical panel, and they can be easily identified by their test button. There are 2 main types of arc fault circuit interrupters, namely branch or feeder arc fault circuit interrupters and combination arc fault circuit interrupters. Branch or feeder arc fault circuit interrupters protect against arcing faults in the branch circuit wiring. Combination arc fault circuit interrupters protect against arcing faults in both the branch circuit wiring and the power cords of appliances. When installing or replacing arc fault circuit interrupters, it is important to follow the manufacturer's instructions carefully. It is also important to test the arc fault circuit interrupters regularly to ensure that they are working properly. Arc fault circuit interrupters are an important safety device that can help to protect your home from fires caused by arcing faults. If you have any questions about arc fault circuit interrupters, consult a qualified electrician. The National Electrical Code, often abbreviated as NEC, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It is part of the National Fire Code series published by the National Fire Protection Association, often abbreviated as NFPA. While the National Electrical Code is not itself a law, it is adopted by state and local jurisdictions in the United States for the purpose of establishing legally binding safety requirements. The National Electrical Code covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect the latest advances in electrical technology and safety practices. The National Electrical Code is an essential resource for electricians, contractors, and other professionals who work with electrical systems. It provides the information they need to design, install, and maintain electrical systems that are safe and reliable. The National Electrical Code is organized into chapters, articles, and sections. Each chapter covers a specific topic, such as wiring methods or overcurrent protection. Each article covers a specific type of electrical system or equipment, such as motors or transformers. Each section covers a specific requirement, such as the size of conductors or the type of overcurrent protection. The National Electrical Code is a complex and comprehensive document, but it is essential for anyone who works with electrical systems. By following the requirements of the National Electrical Code, electricians and other professionals can help to ensure that electrical systems are installed and maintained safely. The National Electrical Code is also used as a reference by insurance companies, building inspectors, and other organizations that are responsible for ensuring electrical safety. The National Electrical Code is an important tool for protecting people and property from electrical hazards. The National Electrical Code is constantly being updated to reflect the latest advances in electrical technology and safety practices. The National Fire Protection Association, which publishes the National Electrical Code, invites public input on proposed changes to the code. This process ensures that the National Electrical Code remains relevant and effective in protecting people and property from electrical hazards. The National Electrical Code is an essential resource for anyone who works with electrical systems. By following the requirements of the National Electrical Code, electricians and other professionals can help to ensure that electrical systems are installed and maintained safely. A neutral conductor is a conductor that carries current back to the source in a single-phase alternating current, often abbreviated as AC, circuit, or serves as the return path for current in a direct current, often abbreviated as DC, circuit. In a balanced three-phase AC circuit, the neutral conductor carries little or no current. The neutral conductor is typically connected to ground at the source, such as a transformer or generator. This grounding provides a return path for fault current, which helps to protect people from electric shock. The neutral conductor is typically identified by its white or grey color. The size of the neutral conductor is typically the same as the size of the phase conductors in a single-phase circuit. In a three-phase circuit, the size of the neutral conductor may be smaller than the size of the phase conductors, depending on the load. The neutral conductor must be properly insulated to prevent it from coming into contact with other conductors or grounded surfaces. If the neutral conductor comes into contact with a grounded surface, it can create a ground fault, which can cause a fire or electric shock. The neutral conductor is an important part of an electrical system. It provides a return path for current and helps to protect people from electric shock. It is important to ensure that the neutral conductor is properly installed and maintained. An overcurrent protective device is a device that is designed to protect an electrical circuit from excessive current. Overcurrent can be caused by a variety of factors, such as short circuits, overloads, and ground faults. Overcurrent protective devices work by interrupting the flow of current when it exceeds a predetermined level. This protects the circuit from damage and prevents fires. There are two main types of overcurrent protective devices, namely fuses and circuit breakers. Fuses are one-time devices that melt when the current exceeds their rating. Circuit breakers are reusable devices that trip when the current exceeds the rating. Fuses are typically used in circuits that are not frequently overloaded, such as lighting circuits. Circuit breakers are typically used in circuits that are more frequently overloaded, such as appliance circuits. Overcurrent protective devices are rated in amps. The amp rating of an overcurrent protective device should be selected based on the ampacity of the conductors in the circuit. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor is determined by its size, insulation type, and ambient temperature. Overcurrent protective devices should be installed in accordance with the National Electrical Code. The National Electrical Code specifies the type and size of overcurrent protective devices that are required for different types of circuits. Overcurrent protective devices are an important part of an electrical system. They protect circuits from damage and prevent fires. It is important to select and install overcurrent protective devices properly. A branch circuit is a circuit that extends from the last overcurrent protective device to the outlets. Outlets are points in the wiring system where current is taken to supply utilization equipment. Branch circuits are classified according to the maximum permitted ampacity of the overcurrent device. The most common branch circuits are 15 amp, 20 amp, 30 amp, and 50 amp circuits. A 15 amp branch circuit is typically used for lighting and small appliances. A 20 amp branch circuit is typically used for general purpose outlets. A 30 amp branch circuit is typically used for clothes dryers and electric ranges. A 50 amp branch circuit is typically used for electric ovens and central air conditioners. Branch circuits must be installed in accordance with the National Electrical Code. The National Electrical Code specifies the type and size of conductors that are required for different types of branch circuits. The National Electrical Code also specifies the number of outlets that are permitted on a branch circuit. Branch circuits are an important part of an electrical system. They provide power to the outlets and protect the wiring system from overcurrent. It is important to install branch circuits properly. The 2017 edition of the National Electrical Code addresses requirements for arc fault circuit interrupter protection. Section 210.12 states that arc fault circuit interrupter protection shall be provided for all 120-volt single-phase, 15-amp and 20-amp branch circuits supplying outlets or devices installed in dwelling units, kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, or similar rooms or areas. According to the National Electrical Code Section 210.4, multi-wire branch circuits must originate from the same panel board or similar distribution equipment. The ungrounded conductors must have the same voltage between them. The grounded conductor, or neutral, of a multi-wire branch circuit can only be connected to one circuit. In addition, where more than one branch circuit supplies more than one device or equipment on the same yoke, a means shall be provided to disconnect simultaneously all ungrounded conductors that supply those devices at the panel board where the branch circuit originated. This is often achieved through the use of a 2-pole or 3-pole circuit breaker. The reasoning for not sharing a neutral is that the neutral conductor could become overloaded if the loads on the two circuits are not balanced. In addition, if one of the circuits has a ground fault, the neutral conductor could become energized, posing a shock hazard. Sharing a neutral wire between two arc fault circuit breakers is not permitted because it can cause nuisance tripping and violates the National Electrical Code.